principle of superposition for electrostatic force. This is the principle which explains what is the net force acting on any charge due to the system of charges. Okay, here is a charge Q. Around this one there is a system of charge. That means this charge is surrounded by a charge Q1 at a distance R1, a charge Q2 at a distance R2, charge Q3 at a distance R3, charge Q4 at a distance R4, similarly charge Q5 at a distance R5, like that nth charge at a distance Rn. Now here on this charge Q, Q1 applies the force, Q2 applies the force, Q3, Q4 and Q1. All the charges will exert the force on this charge Q. Then question is, what is the net charge? What is the net charge at the point Q due to the surrounding charges? That is explained by the principle of superposition for electrostatic force. So according to that principle, net force at a charge or net force on a charge surrounded by number of charges is equal to vector sum of all the forces due to the surrounding charges. That means if you want to know what is the net charge at Q, then find what is the force on Q due to Q1, force on Q due to Q2, force on Q3 on Q, right? Force on Q due to Q4, force on Q due to Qn. Okay, then make the vector sum of all those forces, you will get the net force at the charge Q. Say, if I consider Q1, force acting between Q and Q1 according to Coulomb's law is, I'll write that one as F1. F1 is equal to 1 divided by 4 pi epsilon naught. Charge is now Q and Q1, therefore I write Q into Q1 divided by distance is R1 square. Similarly, force on Q by Q2 is 1 divided by 4 pi epsilon naught Q Q2 divided by R2 square, right? On Q by Q2 distance is R2, therefore F2 force on Q by Q2 is equal to 1 divided by 4 pi epsilon naught charge Q into charge Q2 divided by distance between them, that is R2 square. Similarly, by Q3, right, I'll take that one as F3, that's equal to 1 divided by 4 pi epsilon naught Q Q3 divided by R3 square. Like that, for the last charge, that is force due to Qn on Q, that is Fn is equal to 1 divided by 4 pi epsilon naught Q Qn divided by Rn square. Now these are the forces which are acting on Q due to the surrounding charges. Therefore, what is the total charge? What is the net charge at force? The net force at the charge Q, that is according to the principle, that should be the vector sum of all the forces. Here we have considered the vector sum, that means we have to consider their direction. Okay, in which direction they are acting, whether force is acting from Q to Q3 or from Q3 Q. Okay, like that you have to consider the direction. Okay, so therefore according to this principle, the net force at Q will be F. Okay, alright, like this, F net. Net force on Q will be the vector sum of all these forces, that is F1, F2 plus F3, so on up to Fn. Now if you put the values, right, net force is equal to, now out of these things, all this, right, this is common, I will take that one outside, 1 divided by 4 pi epsilon naught remaining is, right, you can even take that q also outside. Q into, now what is remaining here in this term? Q1 divided by R1 square, plus in this term Q2 divided by R2 square, right, plus so on up to Qn divided by Rn square. Or further you simplify, F net is equal to 1 divided by 4 pi epsilon naught, right, into Q. Now put this one under summation sign, that is summation, right, Q divided by R square. Let us take that variable 1, 2, 3 as I. Okay, so what is the value of I? I is equal to 1 to n. For the first value, if you put I is equal to 1, Qn divided by R1 square, first value, plus summation, plus, right, what is the second value? I is equal to 2, that is Q2 divided by R2 square, plus so on up to last value, that is n, Qn divided by Rn square. Therefore, this gives the net force at the charge q due to the surrounding charges. Therefore, principle of superposition that can be used to find what is the net force in a system of charges. Thank you.